Hi, welcome back. In this lecture, I would like to touch upon some aspects about sustainability of computing, focusing on the aspects related to supercomputing. How sustainable is supercomputing and what are the issues about supercomputing. So it's important to know that supercomputers have become critical tools for any scientific research, data analysis, and any other application that requires massive amounts of computing power. However, with all this power, with all this great power comes a big responsibility towards other people, toward our planet. So this powerful machine, the supercomputers, comes also with several sustainability issues that I want to touch upon in this lecture. So probably the most evident one is really about energy consumption. Supercomputing requires massive amounts of energy to operate, which can lead to a significant environmental impacts and increase energy cost. It turns out that a single supercomputer can consume as much as electricity as a small town. And the energy required to power a supercomputer can contribute to greenhouse gas emission and climate change. On this table here, I'm presenting the three most powerful supercomputers in the world: Frontiers in US, Fugaku in Japan, and Lumi in Finland. That is also the fastest supercomputer in Europe. So we have the number of cores, a number of petaflops. The most important aspects I want to touch on this lecture is really the amount of power that this supercomputer needs to operate. Right, so this column here, you see this is kilowatts, right? And you see here we are in the range of tens of thousands of kilowatts. This means that this is 21 megawatt. I'm really talking about megawatts here. So Fugaku is using 29 megawatts. Lumi, that is our European supercomputer, is using 6 megawatts. So way larger, but still a huge amount of power that requires basically to have its own power plant in order to generate the energy for running a supercomputer. So most likely I scare you a little bit showing this number. So supercomputer needs in some cases dedicated power plant or need to be close to a power plant to run. Together with the amount of power that we need in order to run a supercomputer, we also have the so-called carbon footprint. So carbon footprint refers to the total amount of greenhouse gas emissions, primarily carbon dioxide here. For supercomputer, the carbon footprint includes the energy used to manufacture the supercomputer, most importantly to run one, so that how much power we need to run one, and obviously also to dispose the machine. The energy used to power a supercomputer in the world is typically derived from non-renewable sources such as coal, oil, and natural gas, which are major sources of greenhouse gas emissions. A third important aspect of sustainability is the heat generation, the fact that we need to remove it. So supercomputer generates a tremendous amount of heat during the operation, which must be dissipated to prevent damage to the system. We don't want the processor to melt, right? So we need to remove all this heat in order to prevent the damage to the system. So these also require additional energy. For instance, we need a pump for water, right, to remove the heat, or we need a fan. So we need to put extra energy in order to remove this heat. So these require additional energy to cool the system and can also contribute to the urban heat islands and other environmental concerns. The first concern is the e-waste, the electronic waste. Supercomputers are often replaced every 5-6 years, so they die very, very young. And the reason for that is that technologies of supercomputer become quickly obsolete. And most importantly, we have much more efficient technology. So we have technology that they use waste less power if we wait 4 or 5 years. So we need to replace all the technologies of supercomputing in typically 5-6 years in order to be efficient. However, this leads to a significant amount of e-waste. Many of the components used in supercomputers, such as the processor, the memory modules, contains hazardous materials that cannot be released in the environment. So these materials can pose a risk to the environment if not disposed properly. A fifth issue is really the supply chain issue. The first things to realize is that the production of supercomputers and the production of chips requires a significant amount of resources, including rare earth material that we see here on the table that might be difficult to source sustainability. Additionally, the production and transport of supercomputers from the manufacturer to actually the place requires a large amount of transport. And also this transport, all the logistic involving that can contribute to the carbon emission and other environmental impacts. So how do we address sustainability issue? Well, there are major efforts all around the world, including at KTH, to improve the energy efficiency of a supercomputer, looking at more efficient processor, more efficient memory, network, and better cooling system. Also, we're looking at developing more sustainable supply chains and find ways to recycle or repurpose e-waste. Additionally, there is a lot of research in using renewable energy sources. For instance, the Lumi supercomputing is mostly using renewable energy sources to power supercomputer. And one thing that we are doing at KTH at the PDC, the Computing Center, is actually to reuse the heat that is coming from the supercomputer. So here you see a supercomputer at the bottom and then a big radiator. And then we have cold water going to this in this radiator, the heat, and we heat it up. The water we transport it to other buildings at KTH. It's important during this course that we always reflect about the impact of supercomputing and the impact of the calculation. So whenever we do a large simulation, we should always be reflective about what does it mean. So mostly important, we need to be aware of what is our impact of calculation. I will post on Canvas an important article that is trying to evaluate and estimate what is really the cost and what of power and carbon footprint of the computation that we are doing it. This paper and this researcher also provide a website where we can actually calculate what is our impact of when we do calculation, when we use computing power. They also provide a way a text that we can report in our reports, in our assignment, in our papers on how much power and how much footprint we likely generated during our research or our assignment. So we will also have a small assignment during this course about some sustainability aspect of supercomputing. So this is the last slides of this lecture, and talk to you soon.